Here, problem set question 5. This is the question. There is a manufacturer who owns 2 plants, and each of these plants, plant 1 and plant 2, produce identical output, the same output, according to a production function that is given as this: Q1 K1 L1 K1 L1. Output produced in plant 1 as a function of capital hired by plant 1 and labor hired by plant 1 is given as K1 half L1 half. The production function in plant 2, this is in plant 1. The production function in plant 2 is given by this: Q2 K2 L2. Output produced in plant 2 as a function of capital and labor hired by plant 2 is K2 half L2 half. Notice identical technology. Okay. It may not be the case, but here I am given a question where technologies are identical. It doesn't matter whether they are identical or not. Okay. Factor prices for capital and labor are W is equal to R for both plants. R is equal to 1. W is equal to 1, sorry, R is equal to 1. These are the costs of labor and capital in the 2 plants. In the short run, factor prices are the same. Factor prices are the same, production functions are the same. I have to distinguish between 2 plants. So here we go. In the short run, I am told plant 1, the capital level is fixed at 25. Plant 2, the capital level is fixed at 100. First part of the question. Using short run costs, in the short run rather, how would the firm divide its output between the 2 plants? How would the firm, in the short run, how would the firm divide its output between the 2 plants? You know that 2 plants means I am looking at MR is equal to MC1 is equal to MC2, this condition, optimal division of output between 2 plants. Demand characteristics are not given to you, so you don't have access to MR. So you can only say, you cannot determine how much output is it profitable for the firm to produce overall. But you can still, because you can get this, you can still divide, you can still answer the question, whatever the level of output I produce, how do I divide it between the 2? You can't answer the question how much output you will produce because MR is not given to you. But you can still answer the question, whatever level of output you produce, how do you divide it between the 2 plants? Understand the difference. If I gave you MR, you can tell me using this equation how would you divide output between 2 plants. At the same time, you can tell me what will be the total output the firm will produce. If I gave you MR, demand condition. Now I don't give you MR, you can't tell me what is the profit maximizing level of output. But you can tell me, whatever output I produce, how will I divide it? Okay, this is the important bit. Let's go short run cost. Here we go. I need MC1, you know. That means I need C1, Q1, total cost. Then I'll differentiate to get MC1. I need C2, Q2, total cost in plant 2. Then I'll get MC2 by differentiation. How do I get total cost functions? You already know. I must first locate the conditional input demand for Q units of output. Let's do that. There we go. Production function looks like this. This is Cobb-Douglas, so you know that this will be Q. Let's say, first look at it from plant 1's point of view, Q1. Okay. So this is plant 1's production function. Short run, plant 1's capital is fixed at 25. Okay, A here, L here. I'm going to ask you, what is the cost minimizing input level? What is the cost minimizing input bundle? I ask you this question. Well, you will answer, nonsense. Capital is fixed at 25. I have got to use that capital. There is no such thing as a cost minimizing capital level. I have got to use that capital. Therefore, I'll ask you, okay, I take your point. What is the cost minimizing amount of labor? Again, you will say nonsense. Why? Because if I am going to use this amount of capital and I want to produce this general output Q1, there is only one level of input I must use. It is this. This is your L star. How to, so this, in the short run, the conditional input demands are these. I don't even have to draw my W over R line. There is only one input bundle given this amount of capital that you can use to produce this. How do I find this? Very simple. Substitute 25 into your production function. You want to produce Q1 level of output, right? Your production function is K1 half, L1 half. K1 must be 25, 25 half, L1 half. This is 5. Therefore, L1 must be equal to Q1 over 5 squared. That is Q1 squared over 25. This must be Q1 squared over 25. Okay. So, what is the input bundle? L star is equal to Q1 squared over 25. K star is equal to 25. Therefore, what is the cost? What is the cost function for plant 1? The cost function of plant 1 as a function of output W and R is the cost of using the cost minimizing input function. In other words, Q1 W1 R C1 is what is the cost of labor? 1. 1 times Q1 square over 25 plus R times 25. Got it? Cost function for plant 1. The cost of using the cost minimizing input function. That's the cost function. Okay? It's a function of W is equal to 1 and R is equal to 1. So I won't get any W or R inside here. Only Q. Similarly, for plant 2, what do I know? Plant 2 capital is fixed at 100. Green. So now I am looking at Q2, okay? Q2. This is the output level Q2, not Q1 anymore. Q2. And therefore, the same idea as before. In the short run, there is only one input bundle I can use. And this fella is, you can check, substitute this into the production function, you will get Q2 over squared over 100. Okay, so this bundle is 100. Labor first, Q2 squared over 100 times 100. Again, same idea, substitute into the production function to get this. And once you get that, you notice, given this bundle, C2Q2 is equal to the cost of this bundle, which is 1 times this, the wage costs are 1, so Q2 squared over 100 plus 100. Got it? Got it. Okay? Now let me just derive the marginal cost and divide the optimal amount of output, then we'll keep the rest of tomorrow. Using it now. Next. Now, I have the total cost function, but that is not what I was interested in. I wanted the marginal cost function. So let me get the marginal cost function for plant 1, C1 prime Q1. Differentiate this with respect to output. Therefore, you will get 1 over 25 times 2Q2. This is your marginal cost. Differentiate this with respect to Q2, you will get C2 prime Q2 is equal to 2Q2 over 100, Q2 over 100. Marginal cost of producing output in plant 2. For optimal division of output, if I want to use both plants, I am not yet sure whether I should use both plants or not. But if I want to use both plants, if it is good for me to use both plants, MC1 must be equal to MC2, which means Q2 over 50 must be equal to 2 over 25 Q1, MC2 equals MC1, which allows you to get the expression 50, 25, 2, 4. Q2 is equal to 4. I have got it. What does this tell you? Whatever output level, if the firm is going to use both plants, whatever output level it produces, it must divide it 20%, 80%. Okay, 20%, 80%. Q1 has to be 20%, Q2 has to be 80%. For every unit of output you produce in plant 2, you must every unit of output you produce in plant 1, you should be producing 4 units of output in plant 1. Okay. Here you get Q1 is equal to 1/5 of Q, and Q2, whatever the total output is, 4/5 of Q. 20%, 80%. And you ask me, how do I get this answer? You remember that Q2 is nothing but total output Q minus Q1. Substitute this, make Q1 the subject of the formula, you will get Q1 equal to 20%. Okay, this is the optimal division of output if I use both plants. Okay, let's stop here. We'll continue next lecture. And the question I will begin by answering is,